It's all well and good, isn't it? But we begin to lose dimensions as we look up the ray of creation, don't we? You live in a three-dimensional world. If you walk around and kind of look at your surroundings and sense yourself, you sense those three dimensions. And if you're very keen, you sense at least part of the fourth dimension of time. You sense it as a line, yeah? And we have an imaginary point called now, which doesn't really exist because you can't cut it in half. I mean, you can cut it in half infinitely, you see, and you keep coming back to smaller and smaller units of like, when's now? There it was. It's never now sort of thing. And so it goes from 3 dimensions to 2 dimensions down to 1 dimension. This is how we work. The farther away you get in an octave from where you are, the more dimensions you lose. And the same thing happens when you look up at the sky. Yeah, you see the solar body, for example, not as an orb, not as a 3-dimensional object, but as a flat surface. You go further out, you see the Milky Way as a line in the sky. Yeah, and you see the individual stars that compose our Milky Way as points, and then beyond that, you don't see anything. So 3 dimensions, 2 dimensions, 1 dimension. That's kind of how it works. Let's take it from the other end of the scale. Let's start with the octave of the particle. Okay, the particle is, well, Sam, I could probably rely on you to give a better definition, but I'm going to take a first stab at it. A particle is a convenient concept for us if you get down to the realms of quantum physics, because, you know, for example, we've got protons, neutrons, and electrons. Take the electron, for example. It's more of a probability that it's going to, you know, it accepts certain shapes around the nucleus, but it's a probability of it being somewhere. It's like a bubble, and it forms different figure 8 patterns and, you know, figure 6 patterns and whatnot, like nodes coming off. They've actually seen it now. Same thing with protons and neutrons, but they're a bit more probabilistic of being in the center somewhere rather than being around it, but they're also probabilities in there. So you've kind of like, it's convenient to be able to think of a particle as a little tennis ball, microscopic tennis ball, but it's not quite like that. We've lost pretty much all perception of what they are. After that comes an atom. So the particle being dough, ray being the atom. From that standpoint, I mean, even the word atom really kind of translates, or at least its original Greek meaning is something like, you know, fundamental. They thought that it was the smallest thing, didn't they? The smallest thing possible, until they discovered that atoms are also made of something, and subatomic particles are also made of something. Kinds of things. I mean, muons and quarks and Higgs boson, and, you know, all these kind of charge and force carriers, those sorts of things. But the point is that we get to atom. That would be ray in the moon. If we're taking the idea of organic life, which we'll run with, then after you get the atom, you get the molecule. Things like H2O. You've got hydrogen and oxygen, 2 atoms coming together to make water.
Yeah.
Okay, and so that would be me. That's a microcosm at that point in time, because it can do something. It now has it actually has a cosmic attendance to it. Did you know? We define molecules slightly differently, because they have to have all of the, well, even atoms we define slightly differently, but they have to have all of the physical, chemical, and electrical properties, or unseen world properties that attend it. And so, for example, coffee here, you could say that whatever drips off my finger is a molecule of coffee, because if I split it down too far, it no longer has the coffee-like function in my organism, you see? Understand? It's lost that cosmic property. A molecule of a human is the whole darn thing. Because I can't just give you a cell of my body and say, you know, there I am. I mean, you could get into the argument of DNA, couldn't you? But the idea is that. So molecule, microcosm, cosm. Then what? We get to cells. Yeah, and that is a collection of things. Now, I want you to think of this. This is Fa or Phaton, like planets. A cell is a collection of things. It's got a membrane, doesn't it? It's got the mitochondrial aspect to it, the nucleus aspect to it, all of these enzymes, all of these types of things kind of orbiting around a fixed path, much like the planets in our solar system, right? You see the analogy.
Yeah.
Yeah.
Right? Then above cell comes organ. You've got a liver, you've got a heart, you've got skin. You could call your bones an organ or organs in this context of things. Yeah. But now you've got that solar quality. Your liver radiates a certain frequency, doesn't it? Your lungs radiate a certain frequency. It's got that radiative ability. We'll really get into this when we talk about the I Ching, because each of the organs corresponds to a particular type of radiation, and we can begin to traverse the realms of healing and those kinds of things as well. After organ, what do you have? Got the organism. Interesting, isn't it, right? A collection of organs becomes an organism. So much like La, much like our Milky Way galaxy. And then above organism, you've got species. Right? Humans, we are a species. And then you get to a shock, because you're not, for instance, a kangaroo, are you? Right? There's a big difference between you. Well, actually, there isn't a big difference genetically between you and a kangaroo. There's not even that much difference between you and a peanut, genetically speaking. I mean, you're more than 50% nuts. You can-
Been saying that for years.
Yeah.
Eating nuts is cannibalism.
Oh, okay.
Right. Yeah. No, it's true though. It's true. I mean, there's very little that separates you from, a giraffe, for instance. Yeah, look it up. It's interesting. You're like 78% giraffe and, 52% banana or whatever. I'm serious. It's true. Yeah. Okay, so then you pass over the shock, because right? Do, re, mi, shock, right? From going from our planet to all planets has a shock, just like going from molecules to cells. Big change, isn't it? Yeah. And then between C and Do of the next octave, you've got a shock. So we've gone from the smallest subatomic particle all the way up to a human being, all the way up to the species of human being. Now that is also a ray of creation. Okay, as above, so below. I can't emphasize this enough. It's the same everywhere. As you go through the universe, from the smallest to the absolute grandest. Right, so you pass the shock, then you've got genus, don't you? Genus? See, I'm going to dig back into your 7th grade biology class. After genus. Don't worry, I had.
That's my speciality. I don't do
That's
biology.
all right. Yeah. But interestingly, it goes 7 again. You've got genus, family, order, class, phylum, kingdom, and domain. Kingdoms, right? Domain has a very special term in this work. That would be the thin film of organic life on Earth.
What's the one between class and kingdom?
Huh?
What was the one between class and kingdom?
Phylum, P-H-Y-L-U-M. Phylum. Yeah, good. And that, ladies and gentlemen, is a ray of creation.